Welcome all to our third lecture about XSD. Just reviewing what we've seen on the last two lectures. On the first lecture, we've seen some introduction, characteristics, and the general syntax of XML schema definition documents. And on the last lecture, we've seen the specific syntax regarding the declaration of simple elements and attributes. So now let's finish the specific syntax section with the complex elements as well as with the data types, and finish this topic with some indexes about all elements and facets available from W3C. So how to declare complex elements? First, as we've been learning since some classes before, the definition of complex elements is of elements that are declared at the XSD and that may contain text, data, may contain also other elements, simple or complex, and also may contain some attributes or a mix of the three. So at the XML instances, you will be able to use elements that can be empty elements when the complex element contains no content at all, or complex elements that contain only other elements and no text content, or complex elements that contain only text and not any other element nested to it, or elements that contain both other elements as well as text. And the way of declaring complex elements may vary depending on the design method chosen for writing your XSD file, and we will see now all these three forms of declaring a complex element. So firstly, when using simple method, we declare complex elements as like this. You open the element declaring tag, access column element, you specify a name for that element. All elements must be named. Then you don't use the type attribute at the element opening tag, but you create nested to the element a complex type element for defining the complex type, and nested to the complex type you use any of the indicators we'll still see later on this subsection. But for example, you may use a sequence indicator, access column sequence element, and inside that indicator you declare all elements that this complex type and complex element would have by declaring the access column element, then a name for this nested element, and a type by using the type attribute, and then a prefix column, a type name, which, as with all other examples we've been seeing, can be from the default namespace and prefix access, or can be from any other custom namespace containing any custom type you want. And after the indicator element closes, you declare the eventual attribute as we've seen on the last lecture. Then you close the closing tag of that complex type, and lastly you close the element tag as here. So this is how you declare complex elements by using the simple method. Now let's see how you declare a similar complex element by using another design method, which is the divided method. So remember that the divided method, its main characteristic is that you declare elements and attributes globally, and then you refer from inside complex elements to those globally declared attributes instead of declaring each element completely inside the complex elements or complex types as at the simple method. So, for example here, globally we are declaring two elements, access column element, name nested element 1, and access column element, name nested element 2. And we're setting the type access string on both. Then we are declaring also globally the attribute with a name ABC, for example. And we're setting the type of the attribute to be a certain prefix column df with the default being anything. And later, after we declare the simple elements and the attributes globally, we start declaring the complex elements, in this case a single complex element, which would probably be the future root element, access column element with a name ABC. Then inside and nested to the element, we start declaring the complex type with access column complex type element. And then we use an indicator element, and inside the indicator element we nest all elements that will be nested to this complex element, for example the access column element, but only referring using the ref attribute to the already and previously globally defined elements. For example here, using that document custom prefix in referring to the nested element 1, and at the second element of this complex element, and also using the ref attribute referring to the prefix column nested element 2. So these are two elements nested to the complex element we are declaring, but it works like a simple referentiation to the elements already declared outside and not as a declaration per se. And this is why, in this case, when we refer to external elements, we do not set any name for any of the elements, because the name will be the name of the referentiated elements already declared outside, as well as the types of those elements that have already been declared outside. And you don't have to declare again. The only thing you have to do inside the indicator of the complex type of the complex element is to use the access column element tag and the ref attribute pointing out to the globally declared elements above. And then, after closing the sequence closing tag, you declare the attribute, and in this case also referring to the attribute already defined outside. And you may use at the attribute use for setting the attribute as required, optional, or prohibited. Then you close the complex type and you close the element closing tags. So this is how you declare a complex type using the divided method. And lastly, the design method I appreciate the most, which is the named types method. So as we've seen already, at this declaring method, you first declare the simple types and the attribute, then you declare the complex types, always naming the type. That's why it's called named types method. At the simple type, for example here, we declare it with access column simple type, and then with a name, calling it simple type 1, and with a type for defining the type of the simple type using the prefix, either the access or any other custom prefix, and the name of the type we're setting as the type for the content of this simple type, which later will be set to a simple element. And then for the attribute, it's the same as with divided method. You just declare the attribute completely and globally for being referred later from inside the complex type. Then you declare the complex types by using the access column complex type, and in this case also setting a name, because you're declaring this complex type now globally, and you gotta have a name for referring to it later. Then you open the indicator, for example, access column sequence, and inside the sequence you declare the elements that are to be nested to this complex type. You add the name for the elements, and then you refer to the globally declared simple types already declared outside by using the type attribute and the prefix for the custom namespace, which links to the target namespace of that XSD. For example, DNPM 1982, colon the simple type 1, which is the name of the simple type globally declared that we want to refer. And at the second element, just for showing the possibility of reusing those globally declared types, here we declare another element with another name, nested element 2, and the type we set the same type of the last element with the custom prefix. For example, DNPM 1982, the prefix that links to the target namespace of that XSD, colon the simple type 1, which is the same type we've declared globally outside. So this simple type globally declared is being reused 2 times here at this complex type, and you can reuse it in any complex types and later elements you want. And that's one of the big advantages of this kind of method declaration, named types, or also with the divided method, where you can also do the same reuse. And here, after closing the indicator element, we declare a attribute referring to the globally declared attribute outside by using the ref attribute and then the prefix of that document. For example, DNPM 1982, colon the name of the globally declared attribute, in our case attribute 1, and you can also use the use attribute for defining if the attribute is required, optional, or prohibited. So even at the named types method, you also have to use the ref attribute for referring to the attributes globally declared. But mainly what you'll be doing is referring to global types by using the attribute type inside the declaration of elements, either inside complex types declarations or when referring to the global type at the definition of the future root element, which is declared globally. Now, before we see the kind of content each complex type will have at our document and document instances, let's first see 2 important elements, which are the extension element and the restriction element. So, for extending a previous declared complex type into a new extended type with extra elements or a previous non-existent attribute, use the access column complex content, which is a new element here, and nested to the complex content, use the access column extension element, both inside the complex type, which later can be set as the type for any access element or complex type you want. And in case of extending a base simple type, you use instead the access column simple content. And an important thing here is that when using extension, all the content and respective constraints initially declared for the first complex type we extend is reused automatically at the new extended type. So at the second complex type, you only need to add the new elements in our attribute. So this is a complete example, which I called complex type extension schema, in which we use the named types method design, and initially we set, after the namespaces and prefixes, the simple types with some restrictions, the string type, the email type, and then we start setting the complex types. First, a complex type we call type base. It's just a name example, it can be any name. And observe here that this type base complex type has a sequence of one element named element A of type string type, and see that we gotta use the custom prefix, the NPM 1982, which binds to the target namespace of this XSD document for the named types to be found. In this case, the column string type, which we've set here globally. So now, for demonstrating the extension, we declare another complex type with a new name type extended, and before we add the sequence of the additional elements, first we use these two new elements here, access column complex content. Every complex type has its complex content, and nested to the access complex content, we nest an access column extension element, and we set as the base of this extension the name of the complex type that we're extending. So the base type being extended is the NPM 1982 column type base, which already has a sequence of one element, in our case the element A. Then inside the extension element we set an additional sequence of another element with the access column element and the name element B, and of type NPM 1982 column email type. So this element B refers to another globally declared type, which is the email type, and adds this element to the previously declared element of the type being extended, which is the type base. And then we add also an attribute. If you see here, the type base has no attribute declared, and now we both add the element B and also set the attribute with a name ID and a string type with the use required. So now we have at this type extended a type that is composed by the element A from the type base, of an element B, and of an attribute ID. And lastly, we set that complex extended type to the future root element, which is declared here globally by using the type attribute. So this is how we extend previously declared base types into a new derived type based on that first types declared before. We've seen how to extend a complex type into a more complex one. Now let's see the opposite, which is the restriction of complex elements. Regarding any of its elements, we also use the access complex content, but now combined with a new element called access column restriction, and also both inside a complex type, which later can be set to any complex element you want. And another thing is that, similar to the extension, if the restriction has a simple type as its base, we use, instead of the complex content, the access column simple content as well. So an important thing now, and a differentiation between the restriction and the extension elements, is that except for the attribute of the first complex type being restricted, all other elements declarations must be repeated at the second complex type with equal or greater restrictions. So for example, it's not allowed to have a second complex type restricting a first complex type, and you miss to redeclare any of the first declared components or elements. You must redeclare those elements on the second complex type with at least the same restriction level or with a greater restriction. So the attribute is the only component automatically reused between the two complex types, the first one, the base complex type, and the restricted complex type, if no restriction is needed on it. So if you have an attribute at the base complex type and you have no additional restriction to do on it, you can not redeclare this attribute at the second one, and the first declared attribute will be reused at the second restricted complex type, differently from the elements. And another thing is that although I've put these two elements, extension element as well as the restriction element, at this complex type subsection, both are also usable for extending or restricting simple types and not only complex types. So now let's see a full working example in which we restrict both a simple type as well as a complex type. So at this complex type restriction schema, we first set a very simple string type with a restriction of base string, access column string, and then we declare another simple type of name string restrictor type with a restriction having as base the first simple type, which can be reached using the Daniel Pinheiro 1982 custom prefix column string type. So we set the base of the restriction to the first type that we intend to restrict, and inside the restriction element we add the additional facets or constraints in addition to the data types or eventual facets already declared at the base type. So here we use a base type and then we increase the restriction for that base type. Then we declare a complex type named type base with a sequence of one element named element A of type Daniel PM 1992 colon string type, and we also set the attribute for this complex type after closing the indicator using the access column attribute with the name ID and the type DNP 1982 column string type also. And then we use this complex type as a base type for the restriction of that complex type when declaring another complex type named type restricted. So we open access column complex type and name it as type restricted. The names can be anything. Then we add a access column complex content, and then we use the access column restriction with the base being the type base or the complex type that we are extending at this extended type. And then we repeat, in this case, the only nested element declaration of the base type, but now setting a more restricted type that is the simple type that we use it to restrict the first simple type. And then we also restrict the attribute type. If we didn't want to restrict the type for the attribute, we could just not declare it here, and it would be reused exactly as at the first complex type. But just for showing you that we can also restrict the attribute and not only the elements, we declare the attribute again, but now with the type also being the restricted simple type above, and also now using the attribute use with the value as required. Then we closed the restriction element and the complex content as well as the complex type. And finally, as always, we declare the future root element, setting the last complex type as its type, and in our case, the most restricted complex type with the element A and the attribute set with the most restricted simple type. So in this example, we show you that the restriction element inside simple types as well as at complex types for restricting base, simple or complex type respectively, and then these types can be set to elements later on the document. So now let's start learning about how to define which kind of element each complex type can have, either an empty content or a text-only content or an element-only content or a mixed content. So first, for declaring an empty complex element, we have two ways, and that's why I talked about the extension element and the restriction element before, which is by using an extension of a simple type or a simple content with an initial length of 0, and then setting at the extended type an attribute inside that extension and putting that extension inside a simple content, but in turn inside a complex type, and later setting the complex type to any complex element you want. Or we can simply declare an attribute nested inside a complex type declaration with no further inner element, and then set that empty complex type to an element. So next slide, we'll both use an extension of a simple type with a length of 0 using the extension strategy and the simple content element, and we will also use the more easy way, which is simply declaring an attribute inside a complex element or complex type. And in both cases, what we wanna create is a schema definition that validates this XML document instance or something like this, in which we have, for example, the prologue, the using of the email element, which is the root element, with the definitions of the namespaces, the schema location, and the custom prefix with the custom namespace that's exactly the same as the target namespace of that XSD. Maybe an attribute as well, but as you can see here, with no admitted or allowed content, either text or any element inside the content space of that email complex element. If you try to put any text or use any element even from that XSD here inside, the XSD using any of these two strategies will invalidate that XML instance referred to it. So now let's see the XSD and the two strategies for defining a complex element, in this case the email complex element, as an empty element. So here is the XSD schema, the email named types method empty complex element, in which we declare the schema element with the namespaces and prefixes. Then we set the simple types, and then we set a complex type called email empty with a simple content and an extension element with the base type extending the previous simple type string empty type. And take a look here at this string empty type, that it's a simple type of base string with a max length of 0. So this simple type is a string simple type that allows no number of chars as the content of this simple type. And then we use a complex type called email empty for extending this simple type and adding an attribute named email ID with the type of the attribute Daniel_2 column long type as the other simple type that we declared above, and the use value required. So we have now a complex type extending that simple type with max length 0 and added with an attribute which is the extension itself, and as such we will be able to use the email empty element, which will not validate any number of chars and will have an attribute email ID. So, and then at this another complex type which we call email empty 2, we show the other strategy for creating empty complex type, which is basically start defining the complex type and setting an attribute inside without any elements or simple content. So both of these strategies will do for validating this empty complex type element as we wished. So now let's see the most common example of content configuration for complex elements or complex types, which is what we've been doing the most since we've been exemplifying complex elements. This kind of setting of complex elements only validates content that is not text, and also that is not empty content. So it only accepts content for these elements as being other elements, either simple or other complex elements. So, for example, here we set a simple type and an attribute, both global. Then we declare a complex type and a sequence of two elements, nested element 1 and nested element 2, and reuse the global declared simple type on both as the type using the type attribute. And after closing the indicator, we declare an attribute and refer to the previous declared global attribute by using the ref attribute, as we've done on other examples. And lastly, we set that complex type with those two elements of the simple type globally declared to a future root element at an element declaration, and by setting the type using the attribute type with that most complex previously declared type. By setting that complex type 1 with all the elements and other types nested and set inside using the type attribute for that global element. So this is what we've been doing in most of other examples. And now let's see how to set a complex element for accepting only text as its content. In this case, it won't accept empty content or element content, neither mixed content. For example, we want to validate this email element, in this case a root element, with only this text info as content, as well as an attribute. We don't want the XSD to validate any content using elements or mixed content or even empty content. What we want is that it validates content only if the content is a text. So the way we do is to use at the complex type a simple content element along with an extension element or a restriction, with the text data type being the base of the extension. Let's see the schema example that validates this XML instance. I call it email named types method text only complex element. It declares initially two simple types, a long type and a string type, and then it declares a complex type named email text only type using a simple content with an extension of a base simple type, the NPM 1982 column string type, which is this simple type here, and it extends that simple type by adding an attribute named email ID of type long type and the use required. Then we close the extension elements and then the simple content element. And lastly, we set that complex type that extends that simple type to a simple content of a complex type with an attribute to the future root element declaration email by using the type attribute and the NPM 1982 column email text only type, which is the complex type with a simple content that extends the simple type string type with an attribute. Observe here that neither the simple type, which is the base type, nor the complex type, that extends the base type with a simple content, including the extension of that base type and an attribute. Neither of them includes any element declaration, and what the complex type adds is merely an attribute to extend that base simple string type. So you can't use any element inside because there's no declaration of any element, and you also by default can let the content empty. You gotta use any content that is a text. This is pretty similar to what we used at the empty complex element declaration, but in this case observe that the base type that we extend with the simple content of the complex type is not a 0 length string type, it's a 20 length. So these facets of the simple type are reused at the simple content extension, adding the attribute. So turning back again to the XML document instance, you can use any content for this email element that is a string and that has a max length of 20. And now the last type of content configuration for complex elements is the mixed content setting, which sets the option for you to use the XSD to validate elements that may have as content both a text or element content. For example, at this XML instance, for the email complex element or for its complex type, we set the mixed option as true in order to turn acceptable the use of text content as here and here and here and here and here and here again, as well as elements as contents. And also intentionally, you'll see at the next slide that for the element 2, we turned the mixed to false so that we only could have as contents the expected elements and not text. So for setting the mixed content as allowed at the XSD, here we set the simple types, nothing new here, but at the complex types we simply use the attribute mixed for each complex type. Here the email to, the email from, and here the future root element, which is email. We set the mixed attribute for each of them as we want, so that at the email from and at the email root element we can have mixed content, which means that both text and elements are acceptable, but at the email to complex element we set the mixed type to false, turning back to the default, which is to accept as content only the declared elements and not text. So the only new thing here is the mixed elements set to true or false on each complex type. So that's how we set the possibility for using mixed content at each complex type, at each complex element. So now let's see one important subtopic, which are complex elements indicators. So we have 7 indicators regarding the order, the occurrence, and the grouping of nested elements. And starting from the order indicators, we have the all element, the choice element, and the sequence element. We've already seen a lot the sequence one, but we also have the choice and the all. And for the occurrence indicators, we have the max occurs attribute and the min occurs attribute. Both are set inside the element declaration or inside the other indicators declaration. And we also have the group indicators group and attribute group. So starting with the access column all indicator, we have two specifications. One is that the child elements can appear in any order, and the second that each child element must occur at most once and at least 0. So at the nested element declaration, we can use a attribute mean occurs of 0 or 1 and an attribute of max occurs of only 1. And the declaration of the element all itself can only be 1. So let's jump to the example. For example, here we have this schema with the declaration of simple types, and later with the declaration of this complex type, shape2 type. It's a shape order schema designed with the named types method, where I exemplify the indicators. And here at the complex type with name shape2 type, we use the indicator access column all instead of, for example, access column sequence. We used the access column all, which states that each nested element or child element, for example, name, address, email, city, state, country, and zip code, can appear at the XML instances in any order, not necessarily in this order, and that each of these child elements can occur at least 0 and at most 1 time. So you can't repeat more than any of the elements, but you can set any of these elements to be optional if you use the min occurs equals 0, or you can set any of them to be required if you use the min occurs with a value of 1. And the min occurs and max occurs for the all element itself can only be 1. So at least you have this set of all elements, and at most you have the same set. And individually, each child element can be optional or required and can occur at most 1 time for the whole set. And then we have another order indicator, which is the access column choice. And this indicator specifies that either one child element or another can occur 0 or more times, the one that occurs, but not both of them, or not more than one different child element, except if the multiple choices are set, which we'll see at the example. And the max occurrency at the choice indicator itself, it defines the maximum number of times the choice can occur, more or equal to 0 or unbounded, and the default value is 1. And the min occurs define the minimum number of times the choice can occur, more or equal to 0, and the default is also 1. So if only one choice is allowed, at most one of the elements could be chosen with an occurrency of 0 or more, but if multiple choices are set, then more than one of the child elements could occur, each with an occurrency of 0 or more on every choice. Here we specify a complex type named service type for a shape order, and inside the complex type you use the access column choice, in which you have 3 exclusive options: a priority, mail express, a priority mail, or a first class mail, the 3 of them of type string. And the min occurs is set to 0, which means that the user can leave it empty with no selection, and with a max occurs of 1, which means that we'll have only one chance of selection, and at that one chance or cycle of selection, you gotta choose any of these 3 if you wanna make the optional selection. So the max occurs here could be more than 1 or even unbounded, which means that the user would still choose one of these 3 exclusively, but how many times he wanted, and the same option would appear more than once at the XML instance. Also, any of the child elements could be set to be selected 0 or more times, but it wouldn't make any sense on this case. But you could also use the min occurs and max occurs as you wish it for each option individually. But in the case as we set here, we are only using at most one selection, and at that selection we are choosing only once any of the 3 of these options in a exclusively way. So the third and last order indicator is the sequence, which is the most common used. And the sequence indicator specifies that the child elements must appear in that specific declared order of the XSD, independently from the min or max occurrence of each element. Regarding the sequence element itself, if multiple sequences are allowed, then more than one sequence could appear, but with its child elements always respecting the order despite their individual occurrence number, but the default for the max occurs is 1, which means that only one sequence should be validated, although you could change that if you wished. If the min occurs is set at the sequence itself, it defines the minimum number of times the sequence can occur, more or equal to 0. And if you want to set the sequence element as optional, you just set this attribute min occurs to 0, although the default is 1. So the default is that a sequence order indicator is required and is used at most once, but you can use any min or max occurrence both for the sequence element itself as for any individual child element or nested element. So let's jump again to the example. For example, here at this group, we set a sequence or access column sequence of 2 child elements. The first is the client element and the second is the shape2 element. The client is a simple element and the shape2 is a complex element based on a shape2 type with a lot of other simple elements inside. But the thing here is that the indicator used is a sequence, so these 2 elements at that group must appear in that order declared, first the client and later the shape2, with all nested elements in the declared order. We could set the min or max occurrence here for the sequence, so that we could have more than one sequence, but exactly in the same order each. And we also could set the min and max occurs here for setting if each of these elements are optional, with a min equals 0, the default being 1. The default is not optional, it's required. And with a max occurs of 0 or more for each element individually. So here we set the max occurs to 1, which means that these two elements must appear in this order because of the sequence indicator. Also that the sequence is only one sequence, it does not repeat in the same XML instance, and that the max occurrency for each of these two elements, or for the client element and all the other elements nested to the shift2 complex element, must occur only once. So it's not allowed multiple occurrency for these elements of this sequence. Okay, now the occurrency indicators, which are the two attributes max occurs and min occurs. The access column max occurs indicator specifies the maximum number of times an element can occur, and if unlimited times is permitted, the value for the max occurs attribute should be unbounded. Similarly, the access column min occurs indicators specifies the minimum number of times an element can occur, and if the element can be optional, it should be used the value 0, and if it is required, this indicator attribute should be used with a value of 1 or any other positive value according to the business requirements. So with elements, not attributes, with elements, both ordinary elements as elements that themselves are indicators, for example, as we've seen, the ordering indicators. For elements, you can use these two attributes, the max occurs or the min occurs, and you can set how many times an element can appear, if only one time or if 0 times, if it's prohibited to appear, or even unbounded times, unlimited times, as well as if the element can be optional, if it can not appear at all, or if the element is required. So let's jump to the example. So here at the example, we've already mentioned it, both cases. The case where at a nested element you use the max occurs or the min occurs, for example, to specify that an element is required, if you use the min occurs to equals 1, or for setting if the element can be optional, if you use the min occurs equals 0, and also for setting the max occurrency as either 0 if it's prohibited, or 1 if it can appear only once, or even unbounded or any other specific number of times that element can occur at that complex element. And we've also mentioned examples where the min occurs and max occurs attributes appear at elements that are themselves indicators, for example, at the all indicator, where the min occurs and max occurs can occur only with a value of 1, or at a choice indicator element, or at the sequence, where you could also have a min occurs or max occurs or both appearing. For example, here, when declaring the future root element complex type, we declare a sequence of all the elements declared at those previously declared groups and an additional element here. And we set the min occurs and max occurs of the sequence that's expected to be at the complex type of that future root element shape order list, and with the min occurs with a value 1, which means that the sequence itself is not optional. It must occur at least one time with all the elements in this order, although individually each element could be optional itself, but not the whole sequence. And as max occurs, we use the unbounded value, which means that the same sequence of elements can occur unlimited number of times. So at the future root element, you will be able to use multiple sequences of all these elements, representing each sequence a shape order itself. The whole schema is a list of shape order, and therefore you should be able to use how many orders you want at that list. So that's why the max occurs here is unbounded, and you should have at least one shape order on that list, and that's why the min occurs here is equals 1. So what's important to know here is that the min occurs and max occurs can be set both for the elements that are themselves also indicators as these two elements, min occurs and max occurs, and it can occur in any other element, including simple and complex elements that eventually can be set as child elements or nested elements to the complex type in which we will be using any indicator according to what we expect the schema to validate. And now let's see the last two indicators, which are the group and the attribute group, which are pretty simple. The access column group indicator is used to define related sets of elements, and you must define an indicator inside it to specify the order of these elements that compound the set. So after you have defined a group and use the indicator to specify the order of each child element or nested element, you can refer it in any other definition using the ref attribute as if you were declaring all elements there as usual. So it favors modularization and reuse of the XSD code components, as you can mount a group and reuse that group just by referring to that as if you were repeatedly declaring all the elements in multiple places of your XSD code. And the attribute group similarly defines groups of attributes with no need of any other nested indicator differently from the group element. And also after you define this set of attributes as a group, you can refer this attribute group in any other definition or place of your code just by using the ref attribute. As with the group element, it favors modularization and reuse of your XSD code components, and it's even easier than the group element because you don't have to use any ordering indicator as with the group element. So let's jump again to the example. So here we define two groups of elements, and on both we use the sequence indicator for setting the order of the elements. And here at the client data group, we group all the elements related to the client himself. For example, the client's name of the string type, a simple element, as well as a complex element shape2 with the destination data of that shape order. And also another group of elements also sets the order with the sequence indicator here. You must choose any of the three, either all or choice or sequence, as with complex types or of complex elements. And inside the sequence you put the elements declared, and in this case for the item service group we declare the service of type service type, the item of type item type, and a simple type discount ticket of type string. And in the case of the item, which is a complex element with a complex type, we set the max of years to unbounded, because in any order you can request as many items as you want. And then here, as a single example of an attribute group of name ship order attributes group, we just declare all the attributes that you may use, which are the order ID, the order paid, the order processed, the order shipped, and the order delivered, with base types, and some required, others optional. And then we declare the complex type of that ship order, which is a sequence from where we refer to the element groups. Here are the two groups we've declared on the last slide, and also we declare an attribute group here inside the complex type referring to the attributes group that we've set externally here. So the group indicators are simply to reuse a set of declared elements, for example all the elements of the client's data group and all the elements of the item service data group here. And similarly, the attribute group is just for reusing a certain attribute group, for avoiding you redeclare some or many times these attributes in more than one complex type or complex element. And at this example, finally, we set the future root element with a name of ship order list, and we set the type as the ship order list type with all the declared elements and all declared attributes within it. So this is an example of an XSD with all 7 possible and existent indicators of order, of accuracy, and of grouping. So now let's continue our complex elements subtopic with 2 more elements, the any element and the any attribute element. The any element enables us to extend an XSD document as well as their respective instances with elements not specified by that original schema, and is used nested inside any of the 3 order indicators, which, as you know, are always declared inside complex types, and then these complex types set to a complex element. So these 2 elements are exclusively used at complex types and complex elements, and they leave a placeholder to be filled at that complex type or complex element declaration with 1 or more elements not declared at that primary XSD schema. For example, elements from other XSD schemas that you eventually would import at each instance that also imports that primary XSD. And the any attribute element does pretty much the same, but with attributes. It enables us to extend the XSD document as well as its instances with attributes not specified by the original schema, and is used, as you know, right after the closing of the order indicator inside a complex type set in turn to any complex element. So it also leaves a placeholder for one or more extra attributes, for example those declared at other XSD schemas and not declared specifically at that primary XSD. In both cases, at the any element declaration as well as at the any attribute declaration, the only thing declared at that primary XSD is the place for this placeholder specified by the declaration of any of these two elements, but with not anything defining the specific elements that would eventually take place at the XML instances. So in this first primary XSD document, which I call Music Catalog Part 1, as the name suggests, it is a music catalog schema that will structure a list of musics. On this first XSD document, I declare some simple types, a string type and a date type. Then I declare a complex type, which is the music type, with a sequence of 3 first elements. So this primary document will have only 3 elements describing the music, which are the title, the author, and the date time released, pointing out to the first 2 simple types, string type and a date type. And as you can see here, the news is that we are declaring an access column any element with a min occurs of 0, which means it's optional, and a max occurs of unbounded, which means that we can replace this placeholder with as much other elements as we want. There's no limit to how many elements we can put here, but it's clear that also there's no information about what type or what name or what kind of element is expected to replace this placeholder. So it's a generic placeholder on which you can only set the occurrence, for example, and that will make those instances that implement this XSD more customizable as well as more extensible, because in the instances we'll be able to use to describe the music element these 3 original elements described at the primary XSD document, but also any other elements we decide to add from any other XSD schema or from any other access base type. And here we also use the access column any attribute for also setting a placeholder that can be replaced by any attribute at the instances without any previous knowledge of what kind of attribute or name or type is expected to be used here. And then after defining the music type, we declare the root element globally with the name music catalog and a complex type and a sequence of 1 element named music, and setting the type of that music single element with the music type we've defined previously, and setting the min occurs to 0, so You can even define an empty music catalog. The music elements are optional. And with a max occurs unbounded, which means that we can add as many music elements at that catalog as we want. And each music will have this type already defined with all these elements, these 3 original elements, and as much extra elements as we want, because we've used the access column any to set an unbounded or an unlimited number of placeholders for eventual extra elements added at the XML instances, as well as one single attribute in place of the any attribute placeholder as well. And we use this any attribute not only at the music type as an attribute to the music, but at a placeholder for an attribute at the music catalog itself, or as an attribute for the music catalog, for showing that we can use it in any level of the tree structure elements. Now, this is the second XSD document, which I named Music Catalog Part 2, in which contains some simple types and some extra elements and attributes that are going to be used in place of the placeholders we defined on the primary XSD. So we have here a string type. We also have a simple type named genre type, which is an enumeration of 5 options for genres of that music. And we have the long type, which is a simple long base type. And then we define globally some extra elements as the album name of type string, the record company name, also string, the genre of type genre type, the description of type string, and also for the 2 attributes catalog ID and music ID, we set the long type for both. So we have here 4 extra elements and 2 extra attributes at the second XSD that will be imported along with the primary XSD document to an example XML instance to show you that we can use the elements of this XSD document in place of the placeholders defined at the original or primary XSD. So now let's see the XML instance for both these 2 XSD documents. And here you are, the music catalog XML instance. And for the first time, we are showing you an example of multi-import of XSD documents, or multi implementation of more than one XSD document. So let me just review with you here. So first we define the default namespace from W3C, setting it at this XML instance to the XSI prefix. Then with the XSI prefix we set the schema location, and in our case we have 2 schema locations, the music catalog 1.xsd and the music catalog 2. The target namespace of the first XSD is this one, ending with music catalog part 1, and the target namespace for the second XSD we are implementing here is this another URI ending with music catalog part 2. So these are the target namespaces of the XSD, and these are the 2 XSDs that we are simultaneously importing to this single XML instance. So next we define 2 custom namespaces, one namespace linking to the target namespace of the first XSD, and the other custom namespace linking to the target namespace of the second XSD, in which set both custom namespaces to these two prefixes, Daniel PM 1982 and Daniel PM 1982 Extra. So the Daniel PM 1982 prefix is linked with the first XSD document, and the Daniel PM 1982 Extra prefix is linked to the second XSD document. So we now can use the XML instance code the elements and attributes from both XSDs by using these two prefixes linked to them. So at the root element, which is the music catalog, we are adding 3 musics. The first music element containing all 3 elements that describe the music at the first XSD document, which are the title, the author, and the datetime released. Observe here that we use the first custom prefix, Daniel PM 1982, because these elements have been defined at that first XSD document and not at the second. And then we replace the placeholder for the element at the first XSD with some other elements, actually with all possible elements from the second XSD document, the genre, the album name, the record company name, and the description. And observe here that we use this second namespace because these elements have been defined as extra elements on the second XSD and not on the first, but we can use them here as an element from the first one, which is the music, because we have let the placeholder intentionally for being replaced by any number of extra elements at the XML instances. For example, this one. So this element music, as you remember, has been defined at the first XSD as well as these 3 elements, but these other 4 elements are from another XSD and can only be added to this music element from the first XSD because we've declared the placeholder that would be replaced when the first XSD or any of its instance was extended and had added to it some other extra elements, as we've done by using the second XSD we import at this same instance. In here we add another music element with the 3 describing elements from the first XSD, and then only with part of the elements of the second ID. And these 2 elements replace likewise the element placeholder that we declared using the any element at the first XSD that declares this music element. And also, as in the first music element, we can only add to an element of the first XSD these extra 2 elements from a second XSD because we have already declared at the first XSD the unbounded placeholder for any kind of elements we wanted to add at the XML instance. And then we add a 3rd music to the music catalog list with only the elements declared at the first XSD document and with no extra elements from other XSDs. So in this 3rd music element, we do not use or replace the element placeholder, and we actually don't have to because we've set the content of the access column any element as optional. So in this case we just do not use the replacing for the any element. So now, for closing the complex elements subtopic, let's see the substitution group, which is an attribute that can be used at any element declaration for setting that elements are equivalent to any other previously declared element. So you can create substitutes for previously declared elements at the same XSD by using the substitution group attribute with the value of the name of the element you wanna turn substitutable. So, for example, here you have a first element declared, which is generally called the header element. In this case, I've put the name head element, but you could use any other name. And you want to make this first element substitutable by other substituting elements. In this case, we created 3 alternative elements, and we've used the substitution group attribute with the value of the name of the element that we want to make substitutable by these, in our case the head element. And this means that at the XML instances, anywhere you are expected to use this head element, you could also use any of these 3 substituting elements instead. So you first declare a global head element. They must always, both the substitutable as the substituting elements must be global. If not, it won't work. So you first declare a global head element, then you declare one or more global substituting elements which the user could use in place of the first declared and substitutable one. And also, for avoiding substitutions for any reason and in any instance you wished to prohibit the substitution, you only have to use at the head element this another attribute called block with the value substitution. So for example, here, if we use it, the block attribute here for substitution, then we, at the XML instances, we could not more substitute this first element by any other of the substituting elements of the substitution group for that first element. And regarding the type of the substituting elements, this type must be exactly the same of the type of the first element. For example, here string, or it could be a derived type. For example, a more restricted type based on string type, using facets or any other constraint. But it cannot be a different type not derived from the type of the header element. And in terms of declaration, and regarding the declaration of the type, if the type of the substituting elements are exactly the same as the type of the substitutable element, then you can simply not use the type attribute, and it will be implicit using the type of the first element. But in case it's a derived type, for example, you gotta specify on each substituting element that derived type accordingly. So now let's see a more complete example. So in this example, we use a single XSD document using the divided design method, because as we've said, we have to use global elements in the case of substituting groups. So everything we declare here are global. And first we declare a global attribute named ID of type non-negative integer. Then we declare some simple elements, the from, the to, the message text, and the date time. Then we declare some other simple elements, also global, of names de, para, texto da mensagem, and data hora, which as you can see are in Portuguese, whose names as you can see are written in Portuguese, not in English. The first elements are written in English, and the second set of elements we've written in Portuguese, and for using them as equivalents at any instance that implements this XSD document, that implements this multilanguage letter XSD document, we simply use the substitution group attribute at each substituting global element declared, setting as value for the substituting group the name of the equivalent header element that we want to turn substitutable for these other equivalent elements. So in the case of the G element that we want to be equivalent to the from element, G is the same as from in Portuguese. We just use the substitution group and set as value using the custom prefix for the custom namespace for the target name of this XSD document, and column and the name of the global declared header element we've declared previously that we want this D element to be equivalent. So for the other elements we do exactly the same. For the para element we use the substitution group as well and set as value using the DNP 1982 prefix, column and the name of the second element above, the to element. For the texto da mensagem element, we also use the substitution group and as value DNP 1982 column message text, which is the third simple header element above. And lastly, for the data hora element, we use the substitution group and the value Daniel PM 1982 column date time, which is the fourth header element that we are turning substitutable or equivalent to this other element in Portuguese. So we have 4 elements in English, and then we've defined 4 other elements of the same type. That's why we didn't even specify the type here. And implicitly that means that time is the same to the types of the header elements. And this way we set these 4 substituting elements as equivalents to the 4 also globally declared header elements above. So we have 4 elements in English and 4 elements in Portuguese that are pretty much equivalent to the first ones. So then we set another element in English called letter to be the root element, and at that root element, at the complex type and at the sequence indicator, we add 4 elements in English referring to the 4 declared at the initial of this document, from, to, message text, and date time, as well as we declare the attribute here also referring to the ID attribute declared at the beginning and setting the use as required. And even for the root element, we can also create another root element, in this case the carta element, to be a substituting root element for this other root element previously defined. So at the carta substituting element, we use the substituting group as well with the value the npm 1982 column letter. Letter is the header substitutable element that we now turn equivalent to carta. Exactly the same with the other elements above, but in different levels. These are root elements and these are child elements. So now let's see how our XML instance could be. So in this XML instance, I use all English named elements beginning from the root element, letter. Then I use the children elements from, to, message text, and date time. And as you see, all of them with the English names. But on this second XML instance, that implements the same XSD document as the first instance and directs to the same target namespace using the same custom prefix. I use all elements now in the Portuguese form, starting from the root element, carta, and then the equivalent children elements that we've set with the substitution group to be equivalent to these other header ones, which are de, para, texto da mensagem e and, data, hora. So here, basically what we show you is that all the elements named in English at our XSD are equivalent now by using the substitution group to the other elements named in Portuguese, including the root elements. And in any of the instances, we can use both the English named elements as well as the Portuguese named elements interchangeably. And with the substitution group, we conclude not yet the topic XSD, but the complex types subtopic. So now let's see our last subtopic from the topic XSD, which is the data types and the subcategories of data types, beginning from the string data types. So we've already seen how to use or how to set data types, any of them, at the types and elements of an XSD by using the type attribute or the base attribute, depending on how you declare your element, either in the simple form or at the extended form, specifically the simple element. And this string data types category, as everyone knows, are data types used for values that contain character strings, and they can accept the following restrictions or facets: enumeration, length, max length, mini length, pattern, and whitespace. So here are the string data types that you can use. I've taken this list from this link of W3 Schools. And we have all these string data types to use with the type or base attributes. And with them, you can use these allowed facets as you want. And the next category of data types are the date and time data types, which, as you also can assume, are used for values that contain date and time or some derived types from them, and you can use with these date and time data types these facets here: enumeration, max exclusive and max inclusive, min exclusive and min inclusive, a pattern, and also the white space. So these are all the date and time data types available from W3C default namespace, and with any of them you can use these facets for further restriction of each type. The third category of data types are the numeric data types, and decimal data types are used for numeric values. You can use these facets here: enumeration, fraction digits, max exclusive, max inclusive, min exclusive, min inclusive, pattern, total digits, and white space. And these are all numeric data types available from W3C default namespace. You can use any one of them with these facets according to your business requirements. And lastly, we have a miscellaneous types category with these types, and these are the restrictions allowed with some observations regarding each one of them. You have the enumeration, the length, the max length, and the mini length, the pattern, and also the white space. So these are all data types available from W3C, and if you want to see any specifics of them or any other example of anyone that we've not yet used so far, you can go to W3C schools and search for some example there. And with this, we conclude the specific syntax from the XSD topic, but I still want to show you some other two lists which I also took from W3C schools for consultation, which are the elements index. It's an index with all existing elements available at the default W3C namespace. You can search at the link for any of them, and you have a description for each of them with some examples there, and that you can use to create your own elements and types from them. And our last slide for this topic, which is the same table we've already shown you, with all the facets or restrictions available also from the default namespace from W3C. And with that, we finally conclude our XSD topic with all the introduction and characteristics for XSD documents, with the general syntax about it, including the design methods, and with the complex syntax regarding the simple types, the attributes, the complex types, and the data types, as well as indexes of all elements and facets available from W3C for you. So next we'll have two practical lectures about the codes we've seen so far, for you to be sure how to create the XSD documents as well as the XML instances that implement them, and for you to check the correctness of both the XSD and XML instances and test the validation of the instances against the implemented XML schema documents or XSDs. So thanks for your attention at these 3 theory lectures about XSD, and if you have any doubt, please send me an email or a note through the platform, And you also can review or study all the code we've shown so far, which is available at my GitHub down here. And also you can contact me through my LinkedIn. So until next lectures.